Hi, in this session, we are going to talk about Java's for each loop. Now, this is a new feature, relatively new, about a couple of years back, released with version 5 of Java. Now, before that, there's no such feature. So, in this short video, I'm going to go through 3 points. I'm going to show you how to iterate through an array of primitive types, an array of object reference types using the normal for loop, and I'll replace the normal for loops with the for each loop, the same examples, and I'll round up with advantages and disadvantages of using the for each loop over the normal for loop. Now let's start. Now this is a simple person class, nothing much. I'm using this as an example. It has a single attribute, a name, a constructor which takes in a name, as well as a getter, alright, which returns the name. Now let's look at test. There's a main method in test. Let's deal with primitive types first. I've chosen the integer because it's probably the easiest. Now, let's deal with arrays. This statement on line 3 actually declares an array called A, an int array, and populates it with 6 elements. Okay, the first element is 10, 20, 30, 40, 50, and 60. Now, this is a normal for loop. You would have seen this. During the first iteration, I is 0. During a second iteration, I is 1, and so on until I is 5, okay, which is the last element. And during each iteration, you print out the element's value. So let's save this and compile. So when I run it, no surprise, you print out 10, 20, 30 all the way to 60, the normal for loop. So let's change this so that we make use of the enhanced for loop. So this is how the syntax looks like for int I colon a system.out.print line I. Save it, compile it, run it. Exactly the same output. Now let's examine the difference between the enhanced for loop and the traditional for loop. Now, one obvious thing which you might have noticed is that the enhanced for loop looks very clean and neat. Another thing is there's no looping counter. Now, in the traditional for loop, there is a counter I. Alright? And during the first iteration, I'm printing out A0. And I increase I by 1. I becomes 1. I check if this is true. If it's true, I go in and print, A1. I becomes 2. I check this is still valid. I go in and print A something and so on and so on. The enhanced for loop does not have a counter. Now this is how to read this. For every int or for every integer in A. Alright, A is the array in this case. A is the array in this case. Now what is this I here? This is not a counter. It's just any local variable name. If you don't want to call it I, you can call it number. It's just a local variable name which you choose. Alright, and basically it means that during the first iteration of the enhanced for loop, number here is a local variable which will store the first element in A. Alright, during the second iteration of the for loop, number will be readjusted to refer to the second element in A. During a third iteration of the for loop, number will be adjusted to refer to the third element in A. This will carry on until there are no more elements left in A. So depending on the size of A, the enhanced for loop will basically loop through x number of times. So x is the size of A, or the length of A in this case, the number of elements in A. So one thing you notice, lack of a counter. There's no I. Second thing you notice, you do not have to do a logic check as to whether there's no I in the first place. It's actually smaller than the length of the array. And there's no need to increase the counter because there's no counter in the first place. All right. Now let's take a look at another example. Now in this case, I'm going to use an object reference type example. The person array. So on line 14, I'm declaring a new array P, and P is a stores address of an array object. And how many elements are there? The first person element, John. Second person element, Susan. Mickey, followed by Julie. So P stores address of a person array, which stores the addresses of 4-person objects. Now this is a traditional for loop. Okay, during the first iteration, I'm going uh, to call the getName method of P0, which is the John object. And it's going to print out John. During the second iteration, I'm going to call the getName method of P1, which is Susan, and so on. So let's save this and run it. John, Susan, Mickey, Julie. All right, not surprising. So how do we do this with the enhanced for loop? For person, P colon, no. I can't choose the variable name P because P has been used here already. So for person, okay, system.out.println person.getName. So how do I read this? For every person object in P, go into the for loop. During the first iteration, person here stores the address of the first element in P, which is the John object. During the second iteration, person here will be readjusted to store the address of the second person object. During the third iteration, person will store the address of the third person object in the array P and so on. Same thing, there's no counter, and there's no need to increase the counter. Let's save this and see if this works. Compile. What's the error here? Cannot find symbol P. Oh, I commented out the. Let's try again. Okay. So same output. So we have seen two different ways to go through an array. Now this works for array lists as well, which means that P can be an array list. It doesn't have to be an array. In fact, P can be any type of collection. Okay, but you have been exposed to the arrays and array lists as the two main types of collections. P can be the address of any type of collection. Okay. Now let's go to the third point here, the advantages and disadvantages of each. Now, obviously, the for each loop is very clean, simple. It looks nice. No need for counter. Okay, if you don't need the counter. But disadvantages can only move from the first to the last element. Okay, in that order. You can't jump. You can't move backwards. You can't you can't skip anything. So this is the main disadvantage. What do I mean? Now, let's go back to this person object example. Okay. Now let's say the requirement is I want to print out uh, every other person in P. So I want to print out those at the even positions. So what I can do is um, okay, put it another way. Let's change the question. I want to print out from the back. In other words, I want to print out Julie, followed by Mickey, Susan, and John. Now, using a normal for loop is really simple. All I have to do is int I goes p.length minus 1, as long as it is, bigger or equals to 0, I just decrement the counter. This will work, correct? So during the first iteration, P is going to be 3, and I'll print out Judy. During the second iteration, P is going to be 2, I'll print out Mickey, followed by Susan, followed by John. Now you can't do this using the enhanced for loop. You just can't go backwards. In enhanced for loop, will always start with the first element. During the second iteration, go to the second element, go to the third element, and until the last element. You can't go backwards. You can't skip. You can't say, let me give an example of skipping. For example, the requirement now is I want to print the first, the third, the fifth, and so on. So what do you do? Using a traditional for loop, all you do is I equals to I plus 2, or I plus equals to 2. So this solution is simple. Basically, during the first iteration, I'll print out John. During the second iteration, I'll print out Mickey, okay, which is at position 3, or put in another way, when I is 2. Alright? Now, you can't do this with the enhanced for loop in a simple way. Now, you can do this. What you can do is you have another local Boolean variable which you set to true if it's false, and you set to false if it's true. And depending on the type of the value of the Boolean variable, you may print out the current person's name. Now, which is a um, huge mess. So you will only want to use the enhanced for loop if you need to start from the first element, move to the second, move to the third, and all the way to the last. In that situation, and if you don't need a counter. Sometimes you want to print out a counter. For example, you want to print out the the position together with the name in this case. You want to print out a counter. Okay, what do I mean by that? Oops. For example, I want to print out the position. Let's say I plus 1. Now this is the position plus. Okay, so during the first iteration, I'll print out 1 followed by John. During the second iteration, I'll print out 2 followed by Susan. Okay, this counter thing. So in the event that you want a counter, you can use enhanced for loop, but you need another local variable. You can declare another variable called counter and increase counter at the end of the loop. In which case, personally, I'll prefer to use the normal for loop. Alright, but in very simple situations, where you want to iterate from the first to the last element, use the enhanced for loop. Simple, neat, easy to understand. But for all other circumstances, if you need to do special things, you need to jump from first to the third to the fifth, or you want to move from back to the front, there's no choice. You have to fall back to the traditional for loop. And that's the end of this lecture.